ever stop to wonder how all those machines in a giant factory actually talk to each other? And I'm not talking about just random beeps and whirs. I mean, how do they share information? We're going to look at two key languages that pretty much run our industrial world. One of them is paving the way for the smart factories of the future, and trust me, understanding the difference is a really big deal.
Okay, so here's the big puzzle. Picture a central control room. This is the IT brain of the whole operation. Now, that brain needs to know exactly what's happening right now with thousands of different machines out there on the factory floor. That's the operational technology, or OT. So how do you bridge that gap? How do you get good, reliable data that you can actually understand? Well, that's the core problem we're going to unpack today.
So first up, let's look at the classic, the OG solution, a protocol called Modbus. This thing has been the workhorse of industrial communication for decades. And look, it gets the job done, but, well, as you're about to see, it was built for a much, much simpler time, and it comes with some serious drawbacks.
Right. To get your head around Modbus, imagine an old, dusty warehouse. If you want something, you can't just ask for the pressure data. Nope. Instead, you have to send someone with a little slip of paper that just has a number on it, a shelf number, like 4002. They go to that exact shelf, grab whatever's sitting there, and bring it back. They have no clue what it is, and neither do you, not without looking it up in a separate, manually kept logbook.
So here's how that actually plays out. The central system pings the machine's little brain, its PLC, and says, hey, give me whatever you have at address 4002. The PLC sends back a raw number, 930. Okay, what's 930? The central system then has to pull out that separate manual, find entry 4002, and read that it means speed, and oh, by the way, you need to divide the number by 10. Only then, after all those steps, does it finally figure out the speed is 93. It's just clunky.
And this way of doing things creates a ton of problems. First, it's what we call hard-coupled. The data's meaning is literally handcuffed to that one physical memory address. That makes it incredibly brittle. If a programmer on the factory floor changes that address, just one number, the whole system breaks. The central brain is now getting garbage data. And what if you lose that manual? Well, good luck. The data just becomes a stream of totally meaningless numbers.
And that really brings us to the fundamental limit of Modbus. It's fantastic at telling you where to find a piece of data, but the protocol itself has absolutely no idea what that data actually represents. It's just a location.
Okay, so that was the old way. Now let's talk about the new way, a protocol called OPC-UA. And this isn't just an update, it's a completely different philosophy of how machines should communicate. This is the stuff built for Industry 4.0, and it solves all those Modbus problems by just changing the entire conversation.
So forget the old, dusty warehouse. I want you to picture a modern, smart library. With OPC-UA, you don't go hunting for some cryptic shelf number. You walk up to the library's computer and you search for exactly what you want. In plain English, pressure in reactor 3. And the system doesn't just spit back a number, it gives you a complete self-contained report on that data.
So how does it do this? Well, it's pretty clever. It basically gives every single piece of information its own digital resume. The data carries all of its own context with it. Its name, its units, a description of what it is. It literally introduces itself, so you never need a separate manual to figure out what it means.
The secret sauce that makes all this possible is something called the information model. This is the core structure, the framework that allows data to have all that rich, self-describing context. It's what makes the whole system so incredibly powerful and flexible. Let's break this down. Instead of just asking for address 4002, you can browse for an object, like stir reaction tank 03. Then, inside that, you pick the variable you want, upper pressure, and look at everything you get back. Not just the value, 176, but its unit, pascals, a description that a human can actually read. And you even get related actions, or methods, like a button you could press to start the stir. You get the whole story all in one shot.
This brings us to a really crucial concept, decoupling. The data's meaning is no longer stuck to a physical memory address. An engineer can go and change where that pressure value is stored inside the machine, and you know what? The rest of the system doesn't even care. It just keeps asking for upper pressure by name. This makes the system resilient, flexible, and just so much easier to manage.
So why is this technical difference such a massive game changer for Industry 4.0 and the industrial Internet of Things? Well, it's all about finally, seamlessly connecting that IT brain to the OT factory floor.
I mean, this chart really says it all. You've got Modbus, which is address-based, brittle, has no context, and zero built-in security. Then you've got OPC-UA, which is object-based,
flexible, self-describing, and was built from day one with serious enterprise-grade security. It's a night-and-day difference.
And this difference leads to some huge advantages. Suddenly, IT systems can understand factory data without 1,000 different translation manuals. Adding new machines becomes plug and play because they can literally introduce themselves to the network. And this allows for true smart factory applications, like predictive maintenance. A machine doesn't just report its temperature. It can report that its temperature has been slowly rising for weeks, flagging a potential failure before it happens. That's a level of intelligence you just can't get when you're working with raw, contextless numbers.
You know, if you take just one thing away from this whole explainer, let it be this. Modbus lets machines talk, but OPC-UA lets machines talk meaningfully. It lets them have a real, contextual conversation.
And that really leaves us with one final thought. What happens next? What becomes possible when every single piece of equipment in a factory, from the simplest sensor to the most complex robot, can not only talk, but can actually tell its own story? The possibilities, well, they're just starting to unfold.